Hi everyone, I'm Joan Monteroso and I'll be presenting my thesis topic entitled Enzyme Catalyzed Copolymerization of Caprolactone and Fumaryl Chloride. As a brief background, I first talk about polycaprolactone and its properties, and then I will discuss my thesis idea, its potential applications, and its development as a biomaterial. I will also be showing a relevant patent. Polycaprolactone or PCl is a biodegradable polyester that is semi-crystalline, biocompatible, and miscible with a variety of polymers. It has many applications, which I will discuss later. Anyway, as we can see in its structure, PCl does not have any labile or functional side chains that can undergo cross-linking. But why do we want to cross-link PCl? It is simply because we want to improve the properties of PCl such as its heat stability and processability. The current option for cross-linking PCl is to irradiate it with gamma rays. However, this cross-linking technique is very hard to control since it has very little selectivity in the kinds of bonds that gets broken or formed. Hence, my thesis aims to find another way to cross-link PCl, which is by synthesizing a cross-linkable copolymer of caprolactone and fumaryl chloride. The synthesis process is quite simple. I will be using an enzyme as a catalyst for the ring opening and condensation reaction of caprolactone and fumaryl chloride. What I will do is add all the reagents, caprolactone, fumaryl chloride, and enzyme, to a single vessel in a water bath set at a certain temperature and react them for a certain amount of time. PCl is already used in packaging as in the manufacture of films, coatings, and sealants. It's also used in adhesives and in tissue engineering, especially in scaffolds. Other applications include drug delivery and formulation of other copolymers. Similarly, the cross-linked copolymer will have potential applications in the said categories. The most probable application of the cross-linked copolymer, however, will be in the field of tissue engineering, especially as a synthetic bone graft. In developing the cross-linkable polymer as a biomaterial, the reaction yields during synthesis and also the subsequent cross-linking results will play huge roles in developing the polymer according to its target applications. The synthesis process should be refined. The cross-linking process should also be optimized, and a large number of biocompatibility tests and eventual clinical trials will have to be performed to pave the way for the commercial manufacture of the copolymer. For my relevant patent, someone beat us into synthesizing a cross-linkable PCl derivative, and they named the polymer as polycaprolactone fumarate. This patent was published just this April. We already characterized the polymer with the structure and all. The method by which they synthesized PClF is fortunately quite different as compared to my thesis. They had a separate reaction to synthesize the PCl diol and then reacted this diol with fumaric acid by a condensation reaction. Comparatively, my thesis method should be more efficient since I just mix all the ingredients in one reaction. The downside, however, is that theirs is already proven and patented, while I'm still hoping that I do get a product from my reaction. And that ends my report. Thank you.